heme binding to oxygen. Heme function. The heme groups give myoglobin and hemoglobin, the ability to bind oxygen due to the presence of iron atom. So what is the function of the heme group? Heme group gives myoglobin and hemoglobin the ability to bind oxygen due to the presence of the iron atom. It also contributes to the red color found in muscle and the blood. Myoglobin is found in the muscles, whereas the hemoglobin, it is found in the RBCs. Iron in hemoglobin and myoglobin, it is present in the ferrous state throughout the oxygen binding and release. If it is present in the ferric state, then the oxygen binding and the release will not take place. In redox active enzymes, that is the enzymes involved in the electron transfer and in respiratory chain, iron of heme regularly goes back and forth between ferrous and the ferric state and sometimes ferrile state. So, whenever the electrons are added or the electrons are removed, then the iron atom, it changes. You know that how it is oxidized and how it is removed, reduced. So obviously it is a game of the electrons. When the electrons are added, then the molecule is reduced. If the electrons are removed, then it is oxidized. So the iron atom, as it plays between the oxidation and reduction, it loses and adds the electrons and it is converted to the ferrous and the ferric state. Heme binding to oxygen. Each heme group contains an iron heme binding to oxygen. Each heme group contains an iron atom that is able to bind with the oxygen molecule. The oxygen atom is in the ferrous state, lies between the four pyrrole rings but slightly bent away from the plane. Iron in the heme is kept in the reduced state due to the presence of the non-polar amino acids which are present in the hemoglobin molecule. This is a very important function of the non-polar amino acids which are present in the hemoglobin molecule. What is the function? They keep the iron in the reduced form. The iron has two extra binding sites called the fifth and the sixth coordination site on each side of the protoporphyrin plane. The fifth coordination binds with the proximal histidine and the sixth bind with an oxygen. When oxygen binds to iron, the iron becomes slightly smaller, allowing it to move into the plane of the porphyrin ring. Here you can see the fifth bind with the histidine. This is the imidazole group of the amino acid histidine which is present in the protein chain. And the sixth coordination side of the iron, it binds with the oxygen molecule. A distal histidine binds to the oxygen. Distance means far. The distal histidine is near the same iron. I'll just go back to the diagram. A distal histidine is here. It binds the oxygen. Although the distal histidine, far histidine, is near the same iron atom, but it prefers to bind with the oxygen and it helps in positioning the iron and the oxygen. Whereas the proximal histidine, it binds with the iron, and distal histidine, far off histidine, although it is near the iron atom, it binds to the oxygen. The distal histidine is near the same iron but does not attach to it. This histidine helps to position the oxygen between nitrogen of the imidazole of histidine and the iron atom. The distal histidine will not allow the release of oxygen when iron is in the ferric state. You know that iron always in the ferrous state, it can bind oxygen and it can release oxygen. So histidine, distal histidine will not allow the release of oxygen when the iron is in the ferric state. Here is, here is a very good diagram you can see. This is the distal histidine. It is attached to the protein chain, and this distal histidine is attached to the oxygen atom, whereas the proximal histidine it is attached to the iron atom. Excretion of heme precursors. Excess of heme precursors are excreted either in feces or urine. Water-soluble, colorless porphyrin precursors excreted in urine include delta-amino-levulinic acid, porphoblinogen. Porphoblinogen may be oxidized to form uroporphyrin when exposed to air and light. Uroporphyrinogen, porphyrinogen, that is the intermediates of the porphyrin synthesis, and the urine specimen containing large amount of porphyrinogen. When the urine is allowed to stand for a long time, then the porphyrinogens which are present in the urine, they get darkens in color and the urine of the color darkens. Protoporphyrin is excreted in bile and appears in the feces. Coproporphyrogen may be excreted by either route, feces or urine. Then we come to the types of heme. Heme A. Heme A is made up of all the porphyrins, all the heme, they are made up of porphyrin and iron. Heme A is made up of porphyrin and iron atom. Heme A differ from heme B because the formyl group present in heme A at a ring position 8 is replaced by the methyl group in heme B. We'll just see this. Here you can see the formyl group in heme A, and at the same position in heme B you will see the methyl group. Here you can see the methyl. Again we go to the back slide. Yes. The second change is that hydroxyfurancyl group in heme A is replaced by the vinyl group in heme B. Furancyl group in heme A, and here you can see the vinyl group in heme B. Here I have only shown the different groups. Heme B is the most abundant heme and is present in the hemoglobin and myoglobin of human blood. So hemoglobin and myoglobin contains heme B. Heme C. Heme C differ from heme B, thioether linkage in heme C with the apoprotein. Due to the presence of the thioether linkage, heme C has difficulty in dissociating from the holoprotein in the cytochrome C and helps cytochrome C in its functions. I'll just go to the diagram. Here you can see the protein chain, and since the protein chain is composed of the amino acid, and the amino acid cysteine, it contributes the SH group, and here you can see the thioether linkage of the porphyrin with the protein. Heme C play a crucial role in apoptosis, leading to the cell destruction. And what is the important role in cytochrome C? It helps a cytochrome C. It is due to a presence of thioester linkage. There is a very close contact between the porphyrin and the protein, and heme C has difficulty in dissociating from the holoprotein, and in this way it helps the cytochrome in its function. Heme C, it plays a crucial role in the apoptosis leading to the cell destruction. Heme D. Heme D is another form of heme B. Instead of hydroxylated propionic acid side chain, gamma spirolactone group is present. Heme D reduces oxygen of bacteria present in water with a low oxygen tension. Here we can see the spirolactone group which is present in heme D.